Hi everyone. So in today's video, we're going to be talking about angles. So we're getting now into the real meat of the class. So this is going to be section 6.1 if you're following along in the textbook. So I believe this section is called angle measure. So just to kind of set the scene, we'll be getting into trigonometry a little bit later this week, and we'll see that trigonometry has to do with angles. And so in order to be able to do trigonometry, you really have to understand angles. So today we're going to talk about, what is an angle, what different sorts of angles look like, and we'll also talk about using radians, which is a different unit for measuring angles. Okay, so before we get into defining an angle, there's a few different definitions I want to give you. These are not super important, but I just need to tell them to you in order for the definition that we're about to give to make sense. So just a few definitions. So a line, and these are just kind of good things to know in general. So I'm going to define for you the difference between a line segment, and then something called a ray. So a line is going to go on infinitely in both directions. So whenever you say the word line, people misuse these words all the time, but technically when you say line, that means it extends forever in both directions. So if you want to talk about something that does not do that, then that would be called a line segment. So a line segment would be like, I don't know, if you have a triangle or another shape and you're talking about one of the sides of a shape would not be a line because it doesn't go on forever. It would be a line segment. And then the last one is what's called a ray. So a ray is something, it's kind of like a hybrid. It's where you have one endpoint and then the other end goes on forever. So again, these are not super important. They're not probably going to really come up that much in the class, but I just wanted to tell them to you so that the definition I give you makes a little bit more sense. So the formal definition of an angle, and you might have an idea in your head of like what an angle is, and your idea is probably right, but I just want to give you kind of a more formal definition. So an angle consists of two rays, so rays being like the thing we just defined above, or it could be two line segments. Joined by a common vertex. So I'm going to write a little bit more here to get more into what an angle is, but I'm going to start to draw a picture down below here. So basically what I mean by this is that you have one ray and you have another ray and they're connected to each other via a point that we're calling the common vertex. So when you have an angle, it totally could just be two line segments instead of two rays. So like, for example, in yesterday's lecture, when we were talking about triangles, we were talking about angles within the triangles, right? And those angles within the triangles, those didn't go on forever and ever because they were within a triangle. But typically when we draw an angle, like what I have drawn here below, if you're just drawing the angle by itself, you are typically going to extend the endpoints with this arrow to signify that they're going on forever. Okay, so we have two line segments joined by a common vertex. So the measurement of this angle is basically the amount of rotation it takes to go from one of these rays to the other ray. So kind of picture that like you have a book and you're opening it up, right? Like the amount that you're opening up that book is the measurement of the angle. So I'm going to draw like a little arrow here. That would be the measurement of your angle. So the measure of an angle is the amount of rotation from one ray And so we're going to call the first ray, we're going to call it the initial side. Actually, I'll just underline it instead of using quotes. So in the picture that I have drawn down here, the initial side would be what's down here. To the other ray, and the other ray is what's called the terminal side. And these terms are really not going to come up that much later in the class. It's like really just right now that we're being so technical about angles. So you have your initial side, you have your terminal side. Let me get some color in here. I'm going to give us some color for the angle. So the measurement of the angle is basically how much rotation it takes to go from the initial side to the terminal side. So initially, or in the first part of the video, we're going to be talking about measuring angles using degrees. So in a moment, we'll get to what some common numbers of degrees look like as an angle. So this is, I guess I'll put another arrow here. So that is the, actually, let me leave that out. I don't want to clutter this up too much. Okay, so you can have angles that are both positive or negative. So that's one more thing I want to add before we look at some specific examples. So if the rotation that we're talking about is in the counterclockwise direction, so clockwise, counterclockwise, right, has to do with like which way, like picture if you have a clock and which way the clock hands move, that would be clockwise. Counterclockwise would be backwards from that. So the arrow that I drew here, going from the initial side to the terminal side, that is counterclockwise because that's not the direction that the clock hands would go. So if the rotation is counterclockwise, the angle is positive. So the angle that I drew above in purple, that is an example of a positive angle. If you measure an angle going the other way, so if you do a clockwise rotation, then the angle is negative. So just to quickly draw an example of that, so like a positive angle would be something like what we just drew. So this would be a positive angle. And then a negative angle would be if you start with your initial side, and instead of rotating counterclockwise, you rotate clockwise. So you get something that looks more like this. So this would be a negative angle. And we'll get a lot more into different features of angles in tomorrow's class and then in the future as well. So we'll see that actually any angle, you can measure it in the positive or the negative direction. So you might be wondering, like, why are negative angles a thing? And it's really because we want to be able to capture this idea of like rotating in different directions. So negative and positive angles are different because they represent motion that's going in a different direction. So one of them is rotating clockwise, one of them is rotating counterclockwise. One other thing that is worth mentioning somewhere, and I might as well say it now, is that when we're talking about angles, we're frequently going to use a specific Greek letter to name those angles, and that is what's called theta. So maybe I'll actually just write this in this little space up here. So the Greek, I guess I should capitalize Greek. Letter, so it looks like a capital O with a line through it, and it's pronounced theta, is frequently used for angles. So like, for example, in the drawing that I have on the left, we might put a Greek letter there, theta, to be like, okay, that's the angle that we're talking about. Or you might say, theta is equal to 30 degrees, or theta is equal to 50 degrees, or whatever it is. Okay, so let's do I want to draw some of like the most important angles that are out there, and then I'll ask you to try some yourself. So let's do some, like basically, you can have an angle of any number you want, right? You can have an angle that's like 23 degrees or 41 degrees or pick any number and you can have an angle with that number of degrees in it. But there are certain angles that are really important that come up a lot that it's a good idea to just be able to quickly know what they look like. So, examples of important angles. Okay, so first one we talked about the other day is a 90-degree angle. So that is a right angle. So typically when you draw a 90-degree angle, you do that little like box that we did in the last video, but for the sake of being consistent, I'm just going to draw it as an arrow. So that would be a 90-degree angle. So 90-degree angle looks like, again, like a perfect corner. A 180-degree angle is if you have your initial side, and picture like you have a book and you just take that book and you open it all the way so that it's just sitting flat on a table. So if you do that, you end up with something that looks like this. This would be a 180-degree angle. And I made that a little crooked, but maybe I'll fix it. Oops. It really should just be completely straight. Still a little tilted, that's okay. Okay, so another important one is 360 degrees. So you might hear someone say they're like do a 360, like jumping up the air, turning around 360. So 360 is like a full rotation. So if you start with your initial side and you take and you kind of rotate and you go all the way around and you come back so that the initial and the terminal side are now on top of each other, that is a 360-degree angle. So that would be 360 degrees. A couple other important ones, and we've talked about these ones, we saw these ones actually in the last video. So one of them is a 45-degree angle. So a 45-degree angle is 45 is half of 90, right? So it should be like perfectly halfway to a 90-degree angle. So that is what a 45-degree angle looks like. Other important ones are 30 and 60. So a 30-degree angle is going to be 1/3 of 90. So you can use that to kind of give you an idea of what it should look like, maybe something like this. Hopefully I don't run out of colors. So that would be 30 degrees. And then another important one, as I just said, is 60. So 60 is going to be like if you took that 30-degree angle and you did 2 of them. So maybe something like this. So what color have I not used yet? I'll use red. So this would be a 60-degree angle. So these are angles that you should just kind of be familiar. You should be able to quickly sketch what they look like. Like I said, of course, there are other angles that are in between these, but these are the ones you want to really be familiar with what they look like. Okay, so I want to ask you to take a minute to sketch some different angles. I'm going to ask you to pause the video and try to draw these yourself, and then we'll come back together and go over them. So I would like you to sketch angles. Let me say it this way. Sketch Let's do 120 degrees. Let's do negative 30 degrees. And let's do 405 degrees. So you want to draw them with an arrow. So the arrow is going to be really important, especially for the second two, because we have a negative, and then we'll see that we have one that is more than 360. So especially for angles like that, it's going to be really important that you draw an arrow on them. So make sure you do that when you draw the angle. Okay, so hopefully you paused the video, you did this yourself, and now you're coming back. So 120 degrees, let's think about what that would look like. So we start by drawing our initial side. So 120, I think the best way you can approach these is, again, if you know these angles that are above, you can kind of put them together and use them as a reference to figure out what other angles look like. So for 120, that's going to be more than 90, but less than 180, right? It's going to be between 90 and 180. And specifically, it's going to be exactly 30 degrees more than 90. So it's going to look something like this. It's going to be like you took a 90-degree angle and then you just added an extra turn of 30 degrees to it. So this would be an angle of 120 degrees. Okay, so negative 30, we're starting with our initial side, and it's basically going to look like the 30-degree angle that we have above, but instead of going from the initial side and turning counterclockwise, we're going to go we're going to go clockwise. So it means that we're going to go kind of below this initial side. So it should basically look like this. And again, the important thing is putting in the arrow to signify the fact that our rotation is happening in the clockwise direction to show that it really is a negative angle. Okay, so this last one is probably the trickiest one. So this is 405 degrees. So again, let's think about comparing this to the other angles that we already have. So what angles do we have? We have 180, 360, all these different angles. And notice that 405, that's more than 360. And so what that means is that this is going to be an angle where you're going to go all the way around 360 and then add on a little bit extra. So let's start by drawing our initial side. So I'm just going to start drawing an arrow, and we'll kind of see where that takes us. So if we start here, and let's say we were to go all the way around like this, that would be, and let me make this a little smaller so it can fit. So if we were to stop here, that would be 360. But we're not doing 360, we're doing more than that. So we actually want to keep going, and we're specifically going to keep going an extra 45. And I'm sorry, I still feel like I didn't draw that well. So let me try that again. So we're going around 360, and then we're going an extra 45 degrees. So what we should end up with is something that looks like this. I didn't draw that super well, but basically it should look like a 45-degree angle, but where it's not just that we've gone from 0 to 45, we've actually gone all the way around and then an extra 45. So this would be an angle of 405 degrees. And so again, we'll get more into this in a later lecture. So I'm sorry, you might be looking at this and say, that doesn't look like a 45-degree angle. I know, I didn't draw it that well. Let me just redo it one more time because I don't want you to have something in your notes that doesn't look right. So really, again, it should look like a 45-degree angle. So it's something like this. Okay, I'm happier with that. Anyway, so what I was saying is that you might look at this and say, well, isn't that just the same as a 45-degree angle? But the difference is that there's some extra turning going on. So when I teach this class in person, I like to actually literally stand in front of the class and spin around and say, if I turn by 45 degrees, that looks really different than if I turn all the way around in a circle and then turn an extra 45 degrees. So even though those two angles may in some ways be the same, there's something different about them. And so we'll get more into that in tomorrow's lecture. Okay, so here are some examples of angles. So the next thing we're going to talk about is actually a different way of measuring angles. So we're going to introduce a new unit that is used for measuring angles, and that unit is called radians. So I think most of us, we grow up with degrees. Like I said earlier, like you might think of, oh, someone's doing a 360 turn, or you think in degrees, but we'll see that radians in a lot of ways are actually going to be a kind of like a better choice for how to measure angles. And we're going to be using radians as like the main unit for measuring angles in this class. So it's going to take a little bit of getting used to for sure, but you really, really want to get used to this. It's kind of like if you take a science class where, they really want you to use the metric system, but you're used to using inches and feet. It's that kind of thing where I'm really going to push you to, instead of doing everything in degrees, we're going to need to do stuff in radians. Okay, so radians, again, they're a way to measure angles just like degrees. The main thing that you need to know is that if you have 180 degrees, so let me write this as, how do I want to write this? I'll say conversion. So if you want to kind of convert between radians and degrees, the main thing that you need to know is that 180 degrees is the same thing as pi radians. So when I say pi radians, I literally mean the number pi. So 180 degrees is about equal to 3.14 radians. So we're going to be, when we write things in radians, we're oftentimes going to write it in terms of pi. And again, I really want you to think of this as like literally the number pi, approximately equal to 3.14. So we're going to be, I want to do like a few examples of converting back and forth between radians and degrees, and then we'll get more into this in tomorrow's lecture as well, because it's really, really important that you're really comfortable with going back and forth between radians and degrees. So maybe just to give one quick example. So let's say that we wanted to convert 360 degrees to radians. So we know that 180 is equal to pi radians. So that would tell us that, well, 360 is 2 times 180, right? So instead of it being just pi, it should be 2 pi. So 360 degrees is 2 times 180 degrees. So 360 degrees is equal to 2 pi radians. And we'll see, and for now, I'm going to be writing the word radians. We'll see later on that like typically you actually don't write down radians every time. It's just kind of assumed that you don't have to write the units, but I'll write them for now. Let's do one more, and then we'll get into kind of like how you can, like a method that will always work for converting. So let's say you wanted to convert pi over 2 to degrees. So we know that 180 degrees is pi radians. So pi over 2 is half of pi, right? So pi over 2 is half of pi. So that tells us that pi over 2 radians should be half of 180 degrees, right? 180 degrees and pi radians are the same, so if we're taking half of that, then that should be equal to 90 degrees. So let me highlight this part, because this is really important. This is like, if you know this, that 180 degrees is equal to pi radians, that's really the idea you're going to keep coming back to when you are converting. Okay, so I gave you a couple of examples here where you could just kind of convert between degrees and radians just by kind of like looking at the numbers. I want to show you how a method that will always work for converting between degrees and radians. So I'm going to sidetrack for a second and do an example that's probably going to seem like totally unrelated, just about unit conversion. So let me kind of do a squiggly line or something to separate this out, because this is kind of a side note. So unit conversion. So this is something that you may have learned in science classes that you've taken. So basically, if you're trying to convert from one unit to another, you can always multiply by something called a conversion factor. And basically, what that looks like is a fraction where you have one of your units in the numerator and one of your units in the denominator. So for example, let's say you wanted to, so maybe let me try to write that out. So in general, to convert from one unit to another, you can multiply by a fraction where you're going to have some number of your, let me think how I want to say this, your new units over some number of your old units. And maybe I'll just put in like A and B. And so basically this fraction that you multiply by has like the numerator and the denominator have to be equivalent to each other in order to work. And what will happen is you end up canceling out your old units so that you're left with the new units. So for example, let's say that you wanted to convert, let's say 27 inches to feet. So the way you could do this is you could take the number 27, and we have 27 inches. And what we're going to do is we're going to multiply that by a fraction where we're going to put feet in the numerator and inches in the denominator, because that will allow us to cancel out our unit of inches. So we know that 1 foot is the same thing as 12 inches, right? So what's happening here is that because of how we put these units, the inches are going to cancel out and we'll be left with 27 over 12 feet. So that's why the new units are in the numerator and the old units are in the denominator to cancel out. And so this simplifies to 9/4. So similarly, if we wanted to instead convert, let's say 4 feet to inches, well, then you could take 4 feet and multiply that by 12 inches over 1 foot. Because again, now the old units are going to cancel out and you'll be left with, in this case, 48 and your new units, inches. We're going to use this exact same idea to convert between radians and degrees. So converting between radians and degrees. Okay, so if you are trying to, let's say, go from, let's start with degrees to radians. I feel like I've been not using color. Let's get some color here. So to convert from degrees to radians, you're always going to multiply by, so think back to what we just did in that example with the feet and the inches, right? We want to put the unit that we're trying to get rid of in the denominator. So the unit we're trying to get rid of is degrees, right? We're trying to go from degrees to radians. And so in the denominator, we'll have 180 degrees. And then 180 degrees is the same thing as pi radians. And again, typically you're not going to write the word radians. I'm just writing it for now to get you used to it. So for example, let's say that you wanted to convert 75 degrees to radians. So how would you do that? You could say 75 degrees times pi radians over 180 degrees. So the degree symbol is going to cancel out here, that you have the same unit in the numerator and the denominator, and we're going to be left with radians. So specifically, we'll be left with 75 pi over 180 radians. And by the way, typically when we're working with radians, you don't want to approximate. So you're going to leave the pi in your answer. You're never going to be typing in 3.14 or something like that to a calculator. So what we want to do instead is leave the pi there and focus on reducing this part. So if you go through reducing the fraction 75 over 180, you will get 5 over 12. So we get 5 pi over 12 radians. Okay, so let's now talk about converting the other way. So let's say now that you're trying to convert from radians to degrees. So now we're trying to get rid of the radians. So we're going to put the pi radians in the denominator. And in the numerator, we'll put the 180 degrees because we're trying to convert 2 degrees. So for example, let's say that we were trying to convert, let's say 5 pi over 4. And let me write the word radians. So this is typically when you see something measured in radians, it's usually going to look something like this. It's going to be some kind of a multiple of pi or some kind of a fraction with pi involved, is how things will typically be. Like I said, you're not going to usually see them with decimals or approximations. It's usually going to be in terms of pi. So how do we do this? So same idea as above, but now we're multiplying the other way. So we're going to take 5 pi over 4 radians. And we're going to multiply that by 180 degrees over pi radians. So the radians are going to cancel out. And the pi is also going to cancel out. And so we're going to be left with 5 times 180 degrees over 4, which simplifies to 225 degrees. And we'll see in tomorrow's lecture that there's actually kind of a nicer way to convert things. I think doing this multiplying by 180 over pi, the nice thing about it is that it always works, but it's probably not going to be the best way in the future. So just to kind of get you thinking about this, you could also think of 5 pi over 4 as 5 times pi over 4, right? So if you can figure out what pi over 4 is, you can just take that and multiply it by 5. So that's another way of thinking about that. And again, we'll get into that tomorrow. So I want to do one more example. So like I said, very commonly when we're dealing with radians, they will be given to as something like 5 pi over 4 or pi over 6 or 7 pi over 2 or something involving pi, but not every radian measure looks like that. That's really only kind of like the nice angles. So angles that are like a fraction of 180, you can write as pi over 4, pi over 6, something like that. But you can also have angles that are just something like this. So let's say you have 3 radians. So before we start this, I want you to try to guess approximately what you think it's going to be. And I want you to in order to guess, think about what number is 3 close to in terms of radians. So what do we know about, how to go back and forth between radians and degrees, and what number is 3 close to? So 3 is pretty close to pi, right? Pi is approximately equal to 3.14, so 3 is just a little bit less than that. So that's kind of a hint that the answer we get should be a little bit less than 180 degrees, right? Because 3 is a little bit less than pi. But to figure out exactly what it is, we just go through the same process we've been doing. So we would take 3 radians times 180 degrees over pi radians. The radians are going to cancel out, and we'll be left with 3 times 180 degrees over pi. And if you type that into a calculator, you'll find that that's approximately equal to 171.89 degrees. So like we guessed, it's a little bit less than 180. All right, so that's it for today. So on today's worksheet, I'm going to give you basically a bunch of practice of going back and forth between radians and degrees. And specifically, I want you to go through some of the most important angles in radians so that you can start to get familiar with those. And yeah, tomorrow we will be talking more about angles and more about radians specifically. All right, thank you, and I will see you tomorrow.